In this episode, we take on a skill that feels uncomfortable for many new learners because it sits between security, engineering, and everyday organizational reality, making estimates that leaders can use without pretending you can predict the future perfectly. In security work, people often want a single clean number, like how much will this cost or how many people will we need, but complex systems do not behave like simple shopping lists. The real goal is not to be magically exact. It is to be honest, structured, and defensible, so your estimates are grounded in evidence and assumptions rather than wishful thinking. When estimates turn into fantasy numbers, teams make commitments they cannot keep, and then security suffers because corners get cut under schedule and budget pressure. You are going to learn a beginner-friendly way to think about cost, personnel, and reliability impacts as connected forces, where changing one usually changes the others. By the end, you should be able to explain an estimate as a reasoned story that includes uncertainty, trade-offs, and the conditions under which the estimate is likely to hold. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. Start by defining what an estimate is and what it is not, because many mistakes come from confusing an estimate with a promise. An estimate is a best effort prediction based on what you know now, framed by explicit assumptions and bounded by uncertainty. A promise is a commitment that you will deliver a specific outcome regardless of surprises, and in complex systems that is often unrealistic. Estimation in security engineering matters because resources are limited and leaders must decide what to fund, what to delay, and what risks to accept. If your estimate is too optimistic, the project may fail halfway through and leave the organization in a worse position than before. If your estimate is too pessimistic, leadership may reject important security improvements because they seem impossible. A solid estimate helps decision-makers see the shape of the problem and choose a path that is achievable and responsible. To avoid fantasy numbers, the first habit is to break vague work into clear components that can be reasoned about. Cost, personnel, and reliability are not single blobs. They come from specific activities, dependencies, and constraints. For example, when you say a system will cost more, you should be able to point to drivers like licensing, integration effort, testing effort, ongoing maintenance, training, and monitoring. When you say you need more people, you should be able to explain whether those people are needed for design, operations, incident response, or compliance evidence. When you say reliability will change, you should be able to describe what kind of failure you are considering, such as downtime, degraded performance, or data integrity issues. Even beginners can do this decomposition because it is mainly careful thinking, not advanced math. The key is to replace vague labels with concrete pieces that can be discussed and validated. A second habit is to distinguish one-time impacts from recurring impacts, because mixing them is a classic source of misleading estimates. One-time costs include procurement, initial configuration, initial integration, initial training, and initial security testing. Recurring costs include subscription fees, staffing for operations, patching effort, monitoring effort, periodic assessments, and ongoing vendor support. Personnel needs also shift over time, because a project may need more people during rollout but fewer during steady state, or the opposite if the system is hard to maintain. Reliability impacts also differ between phases, because early deployment may have more instability and later operations may be smoother, or a system may become less reliable as complexity grows. If you do not separate phases, you might underestimate the steady workload that makes security sustainable. A good estimate makes it clear what happens up front and what continues month after month, because leaders often approve projects without fully realizing the long-term operational cost. Now bring reliability into the conversation, because beginners often treat reliability as purely technical when it is deeply connected to cost and staffing. Reliability is about how consistently the system performs its intended function, especially under stress, change, and unexpected events. If you design for higher reliability, you may need redundancy, better monitoring, better testing, and better operational discipline, which can increase cost and staffing. If you accept lower reliability, you may have lower upfront cost, but you could pay later through outages, incident response, and reputational harm. In security contexts, reliability also includes security-relevant reliability, such as the ability to produce logs when needed, the ability to enforce access controls consistently, and the ability to recover from failures without losing integrity. A reliable security control that fails silently is not reliable in the way that matters, because you cannot trust it. So your estimates should treat reliability as a system quality that consumes resources and returns value through reduced disruption and risk. A practical way to avoid fantasy staffing numbers is to think in terms of work volume, work complexity, and work cadence. Work volume is how many items must be handled, like how many systems must be patched, how many alerts must be reviewed, or how many access requests must be processed. Work complexity is how hard each item is, such as whether alerts are mostly false positives or require deep investigation, or whether patching is routine or requires coordinated downtime. Work cadence is how often the work arrives, like daily monitoring versus monthly reporting. When you explain staffing needs using these ideas, you move away from arbitrary headcounts and toward a reasoned model of labor. Even if you do not know exact volumes, you can state ranges and explain what would increase or decrease the workload. That creates estimates that leaders can update as facts become clearer rather than numbers that collapse when reality arrives. Cost estimation becomes more honest when you include not only direct expenses, but also opportunity costs and risk costs, while being careful not to turn risk into imaginary dollars. Direct expenses are payments you can point to, like contracts, licenses, and hardware. Opportunity cost is what the organization cannot do because people and money are tied up, such as delaying other improvements or reducing time available for training. Risk cost is the potential loss from adverse events, like outages, data exposure, or compliance penalties. But risk cost must be handled with humility because it involves probability and uncertain impact. A beginner-safe approach is to discuss risk cost qualitatively and connect it to reliability and control strength rather than claiming a precise dollar savings. For example, you can say that improved monitoring reduces the chance of undetected incidents and shortens response time, which reduces potential impact, without claiming a specific amount saved. The point is to show leaders how investments shift the balance of risk without pretending you can calculate the exact outcome. Another major source of fantasy numbers is ignoring integration and transition work, because people underestimate the effort needed to fit a new solution into the existing environment. Integration includes connecting identity systems, aligning logging formats, fitting into network boundaries, and ensuring the solution works with business workflows. Transition includes migrating data, training users, updating procedures, and running old and new systems in parallel for a time. These efforts consume both cost and personnel and can also affect reliability temporarily because changes introduce instability. A solid estimate explicitly calls out integration and transition as major work streams rather than assuming they will be easy. This is especially important in security because controls that are not integrated often end up bypassed or misused, which creates a false sense of safety. When you account for integration realistically, your estimate becomes more trustworthy and your project more likely to succeed. You also need to be clear about assumptions and constraints, because an estimate without assumptions is just a guess wearing a suit. Assumptions might include how many systems are in scope, how standardized the environment is, how mature existing processes are, and how responsive vendors are to support requests. Constraints might include required timelines, limited maintenance windows, staffing limits, or fixed budget ceilings. By stating assumptions, you make it possible for others to challenge or validate them, which strengthens the estimate rather than weakening it. By stating constraints, you clarify why certain trade-offs may be necessary, such as accepting a slower rollout to preserve reliability or prioritizing the highest-risk systems first. This approach prevents the common trap, where leaders hear a number but do not hear the conditions that make the number plausible. Honest estimation is as much about communicating uncertainty as it is about producing a figure. To keep reliability impacts grounded, you should think in terms of failure scenarios and recovery scenarios rather than abstract reliability labels. A failure scenario describes what it looks like when something goes wrong, such as an authentication outage that blocks users or a logging pipeline failure that hides suspicious activity. A recovery scenario describes how the system returns to normal and what resources are required during that period, such as on-call engineers, vendor escalation, or data restoration. When you estimate reliability impacts, you can discuss how often failures might occur based on complexity and change rate, and how costly recovery will be in time and staffing. This keeps you from saying a system will be highly reliable without explaining what that means operationally. It also helps leaders understand that reliability is purchased through design choices, operational practices, and sometimes redundancy. Even as a beginner, you can grasp that systems fail, and what matters is how gracefully and quickly they recover. A disciplined estimator also checks estimates against reference points, because fantasy numbers often come from working in isolation without comparison. Reference points can be similar past projects, typical support ratios, vendor-provided operational guidance, or known ranges for integration time in comparable environments. This is not about copying numbers blindly, but about using reality as a constraint on imagination. If your estimate is dramatically lower than similar efforts, you should explain what is different and why that difference matters. If your estimate is dramatically higher, you should explain the unique risks or constraints driving it. Reference checking helps you find missing work, like documentation or testing, that often gets forgotten. It also reduces the chance that you accidentally produce numbers that sound nice, but have no relationship to how work actually unfolds. Finally, you should learn to present estimates as ranges with decision options, because leaders make better decisions when they see trade-offs rather than a single fragile number. A range acknowledges uncertainty and allows planning for best-case and worst-case outcomes. Decision options show what you can change to move the estimate, such as reducing scope, extending timeline, accepting lower reliability, or funding more staffing to reduce operational risk. This is not hedging. It is a mature way to align resources with risk tolerance and mission needs. When you provide ranges and options, you also create a path to refine the estimate as information improves, which is how real projects stay under control. The estimate becomes a living tool for governance rather than a one-time guess. The central lesson is that cost, personnel, and reliability are not separate columns on a spreadsheet. They are interlocking parts of system success. When you push for lower cost without adjusting scope or reliability expectations, you often create hidden costs later through rework and incidents. When you underestimate staffing needs, reliability drops because monitoring, patching, and response work falls behind. When you aim for very high reliability without planning the resources to support it, the design becomes fragile because it cannot be operated well. Avoiding fantasy numbers means being explicit about assumptions, separating phases, accounting for integration and operations, and communicating uncertainty honestly. If you can do that, you will produce estimates that leaders can actually use, defend, and adjust as reality becomes clearer, which is exactly what security engineering needs to keep promises grounded in real capability.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.